Hello everyone, welcome to our channel. Let's learn together. In this video, I'll be talking about interpolation techniques. So we now find the real root in terms of interpolation techniques. So whenever the function f of x is not known for the given set of values like x0, x1 and so on up to xn and y0, y1, y2 and so on up to yn. And if we wish to get the intermediate values of y using interpolation techniques, then we'll be using the interpolation technique. The function f of x is called as the interpolating polynomial, and this can be understood from the concept of finite differences. So there are three finite differences like forward difference, backward difference and central difference. I'll be explaining about each one in detail now. First, we'll start with the forward difference. And the forward difference is denoted as delta, okay, in this form. Suppose, where we'll be using this interpolation techniques when the function f of x is not known and we have to find the intermediate values, then we'll be using this interpolation techniques. So coming to forward difference, suppose x0, x1 and so on up to xn be the given values of x, okay, and similarly y0, y1 and so on up to yn be the given values of y. Note that the x values are equally spaced here, okay. Then we define the forward differences as delta y0 is equals to y1 minus y0, delta y1 equals to y2 minus y1 and delta y2 is equals to y3 minus y2 and so on. So this is the first forward difference, okay, and also second forward difference, it will be delta y0 square, that is delta square y0 is second forward difference, okay. Delta square y0 is equals to delta y1 minus delta y0, again delta square y1 is equals to delta y2 minus delta y1, delta square y2 is equals to delta y3 minus delta y2 and so on. This is the second forward difference, okay. So I'll explain it through a table so that you'll understand in detail. So this can be expressed in the form of table, okay. The x values, y values, first forward difference, second, third and fourth and so on, okay. Suppose if we are taking x0 to x4 and y0 to y4, then we will be having 4 forward differences, okay. I am taking up to x0 to x4 and y0 to y4, so we will be having 4 forward differences, fine. Now write the x values, that is x0, x1, x2, x3, x4. Similarly write y values y0, y1, y2, y3 and y4, and this is the interval h between two given values of x, okay. Now we have to calculate first forward difference. First forward difference is this one, right? What we have to write, that is y1 minus y0, which is equals to delta y0. Similarly delta y1 is y2 minus y1, that is delta y1. Again what you will get, delta y2 is y3 minus y2. Difference of these both and difference of these both. Again delta y3 will be y4 minus y3, that is delta y3, okay. Now coming to second forward difference. Second forward difference is del square y0, right? Del square y0 is delta y1 minus delta y0. Delta y1 minus delta y0. The difference of both these gives us delta square y0. That is second difference. Again delta square y1 is delta y2 minus delta y1. Again, delta square y2 is delta y3 minus delta y2. And this will be our second differentiation. Now coming to third, what will be the third? Delta square y1 minus delta square y0 will be the third, which is equals to delta cube. That is third difference, right? Delta cube y0. Again, delta square y2 minus delta square y1 will be delta cube y1. Coming to the fourth differentiation is delta cube y1 minus delta y0, which is equals to delta power 4 y0. So this whole thing will be our forward difference. If you observe from here, this whole thing we call it as the forward differences. Okay, now if y is equals to f of x, where f of x is known, suppose, then the forward difference is, the first forward difference is given by delta f of x is equals to f of x plus h minus f of x, and second forward difference is given as delta square f of x, which is equals to delta f of x plus h minus delta f of x. Similarly, the third, fourth and so on you can write. Okay, so this is all about the forward difference. Now we'll be talking about the backward difference. Coming to the backward difference, it is denoted with reverse delta. Okay, and consider x0, x1, xn and so xn be the given values of x, and y0, y1, yn and so on be the given values of y. Okay, so and here also the values of x are equally spaced, that is with an interval of h, as I have explained during the forward difference. Okay, so now how we'll be defining the backward differences? We define as delta y1, that is backward difference y1, is equals to y1 minus y0, and y2 is y2 minus y1, and backward difference y3 is y3 minus y2. This is the first first backward difference. Okay, similarly the second backward difference will be backward difference square what? Backward difference square of y2 is equals to backward difference of y2 minus y1, and backward difference square of y3 is backward difference y3 minus y2, again y4, which is equals to backward difference y4 minus backward difference y3. Here I've missed writing backward difference. Okay, so I'll just express this in the form of a table. Okay, the table, first what we have to do, we have to write x, y, first backward difference, second, third and fourth. So again here I'm considering x0 to x4 and y0 to y4. Okay, so let's write x0, x1, x2, x3 and x4. Similarly y0, y1, y2, y3 and y4. Okay, now what we have to do, what is the backward difference y1, which is nothing but the difference between y1 minus y0, right? Backward difference y1. Similarly y2 minus y1 is backward difference y2, y3 minus y2 is backward difference y3, y4 minus y3 is backward difference y4. Okay, again we'll be going for second backward difference, which is backward square difference of y2. Okay, which is nothing but backward difference y2 minus backward difference y1. Similarly here backward difference y3. These two subtraction gives us backward difference square of y4. Okay, now coming to the third backward difference, these both subtraction of these both values, that is backward square y3 minus backward square y2, gives us backward cube y3, that is third difference. These two subtractions gives us backward difference cube y4. And coming to fourth, these both differences gives us backward difference power 4 y4. So this is the backward difference table. If you observe, this will be our backward difference. Okay, the y4 from back, the backward difference. Okay. Again, if y is equals to f of x is known, then the first backward difference can be written as minus f of x minus h plus f of x, and the second backward difference can be written as minus delta backward difference f of x minus h plus backward difference f of x, and so on for the third, fourth, and so on. So this is about the backward difference. Now coming to the central difference, suppose consider the same values like x0, x1 and y0, y1 are the given values of y. Then we define the central difference as central difference y1 by 2 is equals to y1 minus y0. Central difference y3 by 2 is y2 minus y1, and so on. Similarly, the second central difference, that is similarly, the second central difference square y1 is equals to first central difference y3 by 2 minus first central difference y1 by 2, and so on. Okay. Now I'll just express this in the form of table, that is x, y, first central difference, second, third, and fourth. Note that I am considering x0 to x4 and y0 to y4. Okay. Now take x0, x1, x2, x3 and x4, y0, y1, y2, y3 and y4. Okay. Now first central difference. What is the first central difference? So that is the difference between y1 minus y0, that is central difference y1 by 2. y2 minus y1 is central difference y3 by 2. Again this one, what y3 minus y2, which is 5 by 2. y4 minus y3, central difference y7 by 2. Again, now coming to the second central difference of these both values will be giving second central difference, that is del square of y1, and again this both difference gives us central difference square of what? Central difference square of y2, and these both difference gives us central difference square of y3. Again, for the third, you have to subtract these both. What you will be getting? Cube of y3 by 2, and these two difference cube of y5 by 2, and finally the fourth central difference is the difference between these two. Okay, del power of y2. Okay, this will be the central difference. So just observe the central difference, okay, which will be these values. Okay, fine. Now if again we take the condition, if y is equals to f of x, where when f of x is known, this is known, okay, then the central difference can be written as first central difference will be central difference of f of x, which is equals to f of x plus h by 2 minus f of x minus h by 2. Similarly, the second central difference can be written as central difference square of f of x is equals to central difference of f of x plus, that is first central difference of f of x plus h by 2 minus f of first central difference of f of x minus h by 2. What is h? H is the interval, or as I've said, the x values are equally spaced, right? So h. Okay, this is all about the central. Now you'll be getting a doubt like when to use the forward difference, backward difference and the central difference, right? So when to use the forward difference? Forward difference. When should we use? So if the table, if the forward difference table, it will be used, the table will be used when the given values of x lies at the starting of the table. Okay, whenever the given values of x lies at the starting of table, then we will be using the forward difference. And when we will be using backward, I think you'll know, right? It will be used when the values of x, lies at end of the table, right? I have shown you with highlighting with black marker, right? So that is the difference between forward and backward, when to use. Okay, now coming to central, when you will be using central, the name itself tells it will be used when the values of x lies, central means at the middle, exactly at middle of the table. Okay, or you can say middle of given values of x. Okay, this is these are the differences, like when to use them. So for forward difference, starting, and for backward, end of the table, and for this, middle of given values of x. So this is all about the interpolation techniques. Okay, and in the next videos I'll be explaining the Newton forward interpolation formula with examples, the backward one, and many more examples I'll be explaining you. Okay, thanks for watching. Do like, share and subscribe for more videos, and do check the playlist of mathematical transformation techniques course for all the videos I have uploaded there. Thank you. Bye.